my great pleasure to introduce my dear friend Ulrich Mohrhoff. Ulrich is a resident of the Sri Aurobindo Ashram, India, for the last 47 years. And he has been doing his physics work from there, teaching physics there, and as you can see, this is his book, which has been quite acclaimed, The World According to Quantum Mechanics. He has a background that goes back to Germany. Once he comes up here, you'll see it's a little difficult to mistake that he's German. And he started at the University of Göttingen and later did some studies in physics at the Indian Institute of Science and has been active as a researcher in theoretical physics since then. So we are very fortunate to have him here. He came to America for a conference in Los Angeles, and so tomorrow he's leaving for India, and so we are very happy to have him to talk to us on quantum mechanics and consciousness 2.0. Ulrich.
So it's a great pleasure for me also to be here and visit the institute of my dear friend Ulrich and maybe say a little bit something of interest. Okay, let's start. This is Erwin Schrödinger, and he is of course known for two things. The Schrödinger equation, which is at the heart of quantum mechanics, and then his eponymous cat. Anybody heard of Schrödinger's cat? Obviously. Any ideas of what Schrödinger wanted to demonstrate with his parable of the poor cat? There was this, you see, quantum mechanics, we will hear that, is about correlations. So when you correlate a contraction, Schrödinger's idea was that there is an atom or a certain sample of nuclear reactive material, and say it has a chance of decaying, so that after an hour, 50-50, the decay has taken place or not. So the decaying particle will then trigger a mechanism that breaks a bottle containing cyanide in a chamber containing a cat, and the poor cat will be dead. So after an hour, there's a 50% chance that the cat is dead or that the cat is still alive. Now, I would prefer to put Ambien into that container, then the cat is either awake or asleep. You know? Now, quantum mechanics, that is the whole issue that Schrödinger is raising here, actually predicts a state in which the cat is in a coherent superposition. These are all technical terms, don't worry about them. But the consequence is really that if you take that quantum mechanical prediction literally, that is to say, you take the mathematical formalism as representing the reality, something physical that actually exists and is as described by this formalism, then you cannot say that the cat is either dead or alive. She is in a superposition of being dead and alive. And Schrödinger just wanted to point out that that is nonsense. And that nonsense is with us for almost 100 years, and people still haven't figured out how we have to understand that formalism, which seems to produce such nonsense. You know, somebody wrote, Schlosshauer, the physicist, wrote very nicely that the formalism of quantum mechanics, mathematical formalism, can be written on a napkin. And all the discussion, all that has been written and said, trying to understand what is there on the napkin, that fills entire libraries. So, okay, now we are starting from a different observation by Schrödinger. He says the world exists in my consciousness. I am aware of it. It exists for me as I perceive it. No? It's my perception. I have, Schrödinger speaks of different spheres of consciousness. So in my sphere of consciousness, there's a representation of something that looks like a world. In your consciousness, there is also a sphere of consciousness that is the world as it is for you, in your consciousness. So then there is this mystery, is that how something that is in my consciousness agrees with something that is in your consciousness. And that common part we call the objective external world. And so the question for Schrödinger was, how do we understand that what is in my consciousness agrees with what is in your consciousness? And then he says there are two ways we could understand this. He speaks, and both of the theses that could be invoked to explain this agreement, both of them he calls irrational and mystical. And the first one he called the hypothesis of the real external world, and the second one is the interesting one, where he says we can understand this only if we understand that we are really only various aspects of the one. He writes about the first hypothesis. To invoke the existence of a real world of bodies which are the causes of sense impressions and produce roughly the same impression on everybody is not to give an explanation at all. In fact, it means laying a completely useless burden on the understanding. Why is that so? If we invoke an external world and explain the agreement of what is in my consciousness and what is in your consciousness by assuming that there is a third kind of world, apart from the one that is in my and in your consciousness, respectively, then we are talking about something that we cannot know at all, because we only know our experience of the world. We do not know any world that causes our experiences. So we can compare the world in my consciousness, I can compare the world in my consciousness with the world in your consciousness through communication, through language. We can talk about it. We can come to agreement. We say, oh yes, we perceive the same thing, so. But we can never ever compare the worlds we perceive with this hypothetical imaginary world that is supposed to cause our perception. And then somehow is supposed to agree with our perception. We have no concept of that agreement at all. We can only work out through language agreement between what I perceive and what you perceive. So, and this, I suppose here the German coming in referring to Kant, but you know, Kant was a major philosophical source for Schrödinger, but he is also one of the greatest philosophers of the modern age. Talk about objectivity. What is objectivity? Before Kant, there was always the idea of a correspondence. So there is an external world, and there are representations or ideas in my consciousness. And these are objective representations if they correspond, if they agree with the external world. And this is precisely the kind of correspondence where Schrödinger said, we can't know anything about if it makes sense at all. So for Kant, that was an entirely new concept that he invented. Objectivity for him meant the ability to think of experiences in our consciousness as a system of objects from which the experiencing subject can detach itself. And in the language of Schrödinger again, he formulated that very nicely. He said, we step with our own person back into the part of an onlooker who does not belong to the world, which by this very procedure becomes an objective world. There the world is there in my consciousness, not out somewhere, it's in my consciousness. But from that world in my consciousness, I step back and observe it, and then I have the ability to conceive of it as if it existed independently of me and my perception. That is objectivity since Kant. Not for the naive physicist of today, of course. So, what he did, placing the subject of empirical science squarely into the human consciousness. By doing that, Kant dispelled many qualms that had been shared by thinkers at the end of the 18th century. You know, there was geometry. The world was described in terms of geometry. Now, geometry is something in the mind we construct. This is a system of ideas. How can that have anything to do with the objective world? So Kant's answer was, well, there's no problem at all, because visual perception and visual imagination, so the visual perception where the world appears to us, and visual imagination where we construct geometry, take place in the same space, which belongs to our minds. Then there was the issue of the mathematical nature of Newton's theory at that time. How can mathematics apply to nature? Mathematics is a creation of the human mind. Kant says, what makes it possible to think that the very thing that makes it possible to think of experiences as aspects of an objective world is precisely the mathematical relations and regularities that obtain between experiences. You know? I'll say a little bit more, just a little bit more about this soon. So the question, the big question, action at a distance. How is it, you know, that was a big issue for Newton himself. How is it possible for the Earth to attract the moon? Is there some kind of elastic string by which the moon is pulled? Newton's law describes the attraction, but certainly doesn't explain it. And then comes Kant and says, but why? Where's the issue? For the moon to be causally related to the Earth is for the moon to stand in a regular mathematical relation to the Earth. It's just the mathematics that makes the whole system of experiences that allows us to take this system of experiences as a system of objects that, as if, think about them, that allows us to think about them as if they existed independently of our experiences. So, so Kant's theory of science, before quantum mechanics came along, it offered a way to talk in realist language about things like electromagnetic waves propagating in vacuum, while at the same time to disavow ontological inclinations. You know, you see here, we talk about electromagnetic waves in classical physics. And these are, again, only mathematical tools. We are able, when, for example, electrons are made to oscillate in an antenna, we can cause electrons to oscillate as a result in another antenna. So that's a transmission of information is possible in that way. So it's a mathematical tool for predicting what happens in that antenna if I know what happens in this antenna. But our naive mentality likes to have a more down-to-earth explanation, and so we invent electromagnetic waves and imagine there is something propagating from here to there. You know, so first the electrons jiggling here, they jiggle something, which is only a mathematical thing, but then people started thinking about it as a physical thing and called it ether. But then again, it doesn't fit with special relativity, so it was not an ether and whatnot. It was nothing and yet it was not nothing. So you get all that nonsense when you take a mathematical tool for making prediction and use it, think about it as if it were a reality in itself, a physical reality. You know, you transmogrify mathematics into a physical reality, and that ever leads to trouble. It already leads to trouble in classical times, but you see, that's what I meant here. You can talk that language, that pseudo-realistic language, and at the same time say, no, it's not ontological. I don't mean really that. These are just structures in my experience. So that was all nicely possible to think in pseudo-realistic terms, and at the same time you say, no, but it's not really realistic. We are just using this language. So this whole classical physics was considered, therefore, to be tightly linked with or this whole Kantian theory of science was considered to be tightly linked with classical physics and to make the latter philosophically acceptable. And then quantum mechanics happened. And here, this is a nice quotation from David Mermin. It's a very well-known physicist, at least among physicists, and highly respected, especially by me. He wrote, all the verities of the preceding 2 centuries, held by physicists and ordinary people alike, simply fell apart, collapsed. We had to start all over again, and we came up with something that worked just beautifully, but was so strange that nobody had any idea what it meant except Niels Bohr, and practically nobody could understand him. So, I'll have to say more about Niels Bohr. An important aspect in Kant's thinking was that he considered the spatial resolution of human sensory experience. You know, we can use magnifying glasses to help ourselves to a little higher resolution in detail, a more precise, accurate spatial resolution. He was kind of thinking that there's no limit to that. Theoretically, ideally, we can assume that the spatial resolution of human sensory experience was unlimited. And that's precisely what made it possible to think of the objective world as a system and as a synthesis of sense impression. I should say the other way around, to think of a synthesis of sense impressions as if it were an objective world existing independently of our sense impressions. The organizing principles here in this synthesis were 3. The idea of substance. When we think of something as a substance, we mean something that makes it possible for its concept. It's just an idea that makes it possible for me to think of my perception as connected not by me in my experience, but in an object out there. And then there's another category, the concept of causality. That is precisely what makes it possible for me to think of successive perceptions as objectively connected. So not only connected in my consciousness, but objectively. We need a concept that enables us to think of a succession of perceptions in time as an objective sequence of events. And finally, reciprocal action, interaction, is a concept that makes it possible for me to think of simultaneous perception. So something perceived here, something perceived there, as objectively connected. You know, not only connected in my consciousness, but there is a connection outside of me that allows me to think of this whole system of experiences as experiences of an external objective world. And so quantum mechanics makes it impossible to think of atoms and subatomic particles as sense impressions organized into objects, or bundles of properties inherent in a substance, or causally evolving, re-identifiable objects. nor are atoms and particles to be found in the theory's mathematical structure, which is a calculus designed to correlate measurement outcomes, which means to assign probabilities to possible measurement outcomes on the basis of actual outcomes. So what are they? What are particles and atoms, and atoms and subatomic particles? Where are they to be found? And how can measurements play a leading role in the general theoretical framework of modern physics? You know? So you can imagine the general consternation that was created by quantum, by the advent of quantum mechanics. So there are two ways to go now. There is this wave function, which is governed by Schrödinger's equation. The symbol, Greek symbol, letter psi is used. We can think of it, and we should think of it, as a probability algorithm. That is to say, a mathematical tool for calculating probabilities. And then we have to ponder the nature of the events to which the probabilities are assigned. That's a big issue then. Or, the other alternative is to treat the wave function as representing the actual state of a physical system, and that means going down the rabbit hole. Now, don't dwell much on that meat grinder here. It's just illustrating what the wave function, which is the central tool of, mathematical tool of quantum mechanics, what it does. You insert some information, you get out some information. You know, you insert the outcome that you have obtained at the time at which you have obtained it. Then you insert a possible outcome of another measurement which is made at another time t2, and if you insert all that information, out pops the probability of the possible outcome based on the actual outcome, an actual outcome. So, now we come, why do I say quantum mechanics 2.0? Because there was quantum mechanics and consciousness 1.0. That is something that was relatively popular at the very beginning of quantum mechanics, and that is a consequence of when one chooses to go down the rabbit hole. It means treating every physical object, including every measurement apparatus, as a quantum system. It means treating every measurement outcome as a possibility. It means either to transmogrify all possible possibilities into actualities, and then you get something like the so-called many worlds theory. You see, that takes us back to Schrödinger's cat here. What the wave function actually predicts is that if after 1 hour we look to see whether the cat is awake or asleep, there is a probability to finding it awake and a probability of finding it awake. No problem, no mystery, no issue. But if you take the wave function for presenting an actual physical system, in this case the system that contains the container of ambient and the cat, then you end up, when you take that which is only an algorithm for assigning probabilities to possibilities, when you take the possibilities as actually existing, no? you create a huge amount of problems. So, and there are also many and ever more absurd attempts to solve this problem without understanding that it is a pseudo problem born of the false assumption that this mathematical tool represents in some direct manner a physical reality. So you take all possibilities for actualities, you get the many worlds interpretation. Or you can give consciousness, the consciousness of the observer, the magical power to transform some possibilities into actualities. You know? that idea that consciousness somehow does that in some magical way, acting on some physical reality represented by the wave function, and then whenever a measurement is made, kind of collapsing it or reducing it, or in other words, turning certain possibilities into actualities. So that was consciousness, quantum mechanics and consciousness 1.0. Going the other way, we have to take a stand on the nature of the events that quantum mechanics serves to correlate. And here is a new way of thinking about quantum mechanics that has entered the scene shortly after 2001, let's say this millennium, which is called Cubism. Originally the name refers to, is an abbreviation to quantum Bayesianism. Bayesianism is a certain way of thinking about probabilities as subjective. Probabilities are always subjective assignments by the individual made on the basis of information that is accessible to the individual. It's actually a very obvious way to think about probabilities. But nevertheless, it was a big new idea, apparently new idea, and Mermin then celebrated it as big a break with 20th century ways of thinking about science, as Cubism was with 19th century ways of thinking about art. But it wasn't really so. You see, Bohr, like the other hedgehog, was already there. So I talked with Upanishads, what is the other hedgehog? That refers to a Grimm's fairy tale where there is a race between a rabbit and a hedgehog. The rabbit and the hedgehog enter into a race, who is the first to reach that other place, and the rabbit runs and runs and runs, and when he arrives, the hedgehog is already there. Then he says, let's run back. And again, the rabbit races and races, and the hedgehog is already there. So, of course, there were two hedgehogs, They played a trick on the rabbit. And so I'm referring to the other hedgehog, who was already there. The great merit, I won't say more about Cubism here, but the great merit of this apparently new way of thinking lies in correctly identifying the events to which and on the basis of which quantum mechanics assigns probabilities. And they are experiences. In the more traditional philosophy, they're known as phenomena or appearances. And so once again the question is, as it was for Kant, how is objective science possible? If we are only talking about experiences, how does it become objective? How is objective science possible? When we start, and very, very directly in quantum mechanics only refer to experiences and correlations between experiences. And so that is where Niels Bohr enters, who had figured this out by 1930. But you see, it was so difficult to reconcile the old Kantian way of thinking with this new theory that, as Mermin previously said here, I quoted him, nobody understood Bohr. And that's true, because it was so hard to reconcile these ideas. So much of the discussion centered around this question. How can this theory be objective? How can it be an objective theory? Quite simply, it was quite simple what Bohr figured out in the end, and yet it was so hard for people to accept it. Kant had assumed that the spatial resolution of human sensory experience was unlimited, and Bohr realized that it was not. But he accepted Kant's premise that, these are Kant's words, space and time are only forms of sensible intuition. Now, intuition is an English translation of a difficult German word. It covers perception, imagination, basically everything that takes place in space and time, in the space and time of human consciousness. So forms of space and time are only forms of sensible intuition, and therefore only conditions of the existence of things as appearances, as experiences. And Bohr, like Kant, insisted that all physical concepts owe their meanings to what he called, Bohr's language, our ordinary forms of perception, or space and time. So that's a very, very important issue here, that all the concepts we use in physics derive their meaning in one way or another to the way we experience space and time, to our experience of space and time. And now is another thing that Bohr said: the facts which are, and it's very, very true, the facts which are revealed to us by the quantum theory lie outside the domain of our ordinary forms of perception, space and time. And if all concepts we have at our disposal derive their meanings from our forms of perception, how can we possibly talk about what lies outside the domain of our ordinary forms of perception? So, Bohr's answer, we can only talk about those facts which lie outside that domain by talking about the detailed specification of the experimental conditions under which evidence is gained. So that seems like a very naive kind of superficial kind of theory. We call it instrumentalism. You talk about the behavior of instruments. But people who say that, who kind of denigrate Bohr by saying, oh, but he is an instrumentalist. He says we can only talk about instruments and their correlations in their behavior. But there's this big, big insight that what lies beyond the instruments, with which we reach into a domain that is beyond our ordinary forms of perception, beyond space and time. We have no concepts. We are not able to talk about this domain. The only way we are able to talk about it is by talking about measuring instruments. But here's something that goes much further. The experimental conditions do not simply reveal those facts which are revealed by the quantum theory. They make them possible in the first place. Now let that sink in, I mean, of course, here's a lot of stuff that takes a lot of time to sink in, really. So maybe if it sinks into your subconsciousness after some time, it will pop up again. Maybe when you wake up tomorrow morning, you'll know a little more. Here's an example, an ideal position in measurement. You use detectors, an array of detectors. Each detector monitors a particular region of space. And then one detector clicks, and that indicates that something has been detected, something is present in that region which is monitored by that particular detector. Now here's an obvious question. Was the click caused by something that arrived in that region and then caused the detector to click? No, wrong way of thinking. The click constitutes, the very click as an experience constitutes the presence of something in that region. Without the click, there is nothing there. But what is more, without the detector, there is no there. The detector defines a there that we can then attribute to something, and then the detector clicks, and then we know there is something. And that something can then be identified and labeled. That is the whole process of experimental physics, how we do that, how we label the clicks and how we connect them. That's another story. So why do measurements then play such a leading role in the general theoretical framework of modern physics? And today, this is every physicist, most physicists who actually think about those deep foundational issues. How can measurements be special? They are in a certain way, they are just physical operations, physical things that happen, like there is an interaction between a quantum system and a measurement apparatus, and there are interactions between quantum systems. Why is the measurement apparatus different from ordinary quantum systems? And here is why. Because each measurement interfaces to reality. There's a reality that is directly accessible to sensory experience. And this can be described in ordinary, object-centered language. We always, whatever we talk about objects there in the physical domain. This can be described, this reality can be described in ordinary language using concepts whose meanings are rooted in logic and our forms of perception, space and time. And then there is this reality that is not directly experienced by us, and to this neither the physical concepts at our disposal nor the language of objects can be applied except by some really ambiguous extrapolation via measurement procedures. That is to say, now when we want to talk about what goes on between one measurement and another, if we only know the correlations between measurements, we have to start inventing stories, and stories get quite convoluted and are basically totally unnecessary. They don't contribute anything to our understanding. On the contrary, they just create a lot of confusion. Because what we actually have is just probabilistic correlations between measurement outcomes. So Bohr simply said the physical content of quantum mechanics is exhausted by its power to formulate statistical laws governing observations obtained under conditions specified in plain language. But there's something to be learned. So this is not the end of the story. So just look at the two diagrams on the right. It's depicting a situation where two particles seem to collide. There's a particle entering from above, from the north, and another one coming from below, from the south, and they scatter each other. We are considering this particular possibilities, two particles coming in like this, and two particles going out like this, one going westward, one going eastward. And then in situations where it is simply absolutely impossible to distinguish between these two particles, there is the question, now which particle is which? Is the particle that came out traveling westward the one that came in from the north, or is it the one that came in from the south? Which of the two situations actually happened? And quantum mechanics is absolutely clear about this. It's a meaningless question. We simply cannot say which of the two possibilities happened. And the right way of thinking about this kind of situation is that we are not really dealing here with two objects, but with one and the same object. That one and the same object moves both northward and southward initially, and it moves both eastward and westward eventually. Now, if you say it in that way, you will see immediately that the question which is which no longer makes sense, because you're dealing with the same thing, doing two things. This conclusion that we are actually dealing just with one particle, where there actually seemed to be two particles, that was something, Schrödinger here emphasizes the importance of this conclusion. Our modern atoms, or the importance of this behavior here, and the impossibility of saying which is which. So Schrödinger says our modern atoms must no longer be regarded as identifiable individuals. This is a stronger deviation from the original idea of an atom than anybody has ever contemplated. We must be prepared for anything. So, thoroughly explained what is written here. And Richard Fineman, or you know everyone, very famous physicist of the previous century, in his Nobel lecture, he said, I received a telephone call one day at a graduate school at Princeton from Professor Wheeler, in which he said, I know why all electrons have the same charge and the same mass. Why? Because they're all the same electron. So, same idea. And then Wheeler, together with Meissner and Thorne, in a very well-known textbook, they write, no acceptable explanation for the miraculous identity of particles of the same type has ever been put forward. That identity must be regarded not as a triviality, but as a central mystery of physics. Now, I say, why only particles of the same type? You know, when the particles carry identity tags, which simply means that they're of different types, we can distinguish them. So here, in this picture, I have attached colors as labels, you know. When you then say which particle, which incoming particle came out moving westward, you can say, of course, the particle coming from the north. The left possibility has been realized, not the right possibility. Or the other, so you can distinguish between these two situations because the particles, some identity tags have been attached to those particles. But that doesn't change the fact that if you think of the particles without the identity tags attached to them, you still have to think of them as being one and the same thing doing two things at the same time. So, a particle observed here with these properties and a particle observed there with those properties should be regarded as one and the same thing. If we go beyond where Bohr kind of said, beyond that we shouldn't go, it becomes kind of risky, you know, we just should. But if particles are more than correlations between detector clicks, you know, then we have to go the whole way and conclude ultimately there is only one particle. So I say, in other words, the overall number of particles is just one. Now I want to go back to this mystery for Schrödinger about the fact that our experiences somehow agree with each other. He rejected the idea, the hypothesis of the real external world. He embraced the idea that we are all really only various aspects of the one. And differently expressed by him, the multiplicity of minds or consciousnesses is only apparent. In truth, there is only one mind. This is the doctrine of the Upanishads, and not only the Upanishads. I should say the overall number of minds is just one. You know? So, at the far end of consciousness, just one mind. At the far subjective end. At the far objective end, again, only one thing that then appears to us as many things because it appears many times. It manifests itself as many things, but quantum mechanics forces us to think of what ultimately is there is one and the same thing, and what constitutes the forms, the objects, are relations, spatial relations between this one thing and this one thing. Particle here, particle there, the spatial relation between them, many particles, many spatial relations, you get objects, you get atoms, you get molecules, you get things that are made of molecules. But at the far objective end, one thing. At the far subjective end, one thing. And the theory of the Upanishads is, of course, that this one thing is one thing. So, I'm referring now to the Upanishads, and for me the authority on the Upanishads is Schrödinger. So according to the Upanishads, the world is a manifestation of the one to the same one. As that which is manifesting itself, we can think of it as a being or a substance. Sanskrit term would be sat. And as that to which the world is manifested, we call the one a self or a consciousness. Chit, Sanskrit terms. So then we can then ask, so what is the role of atoms and subatomic particles? They are instrumental. That is an important new insight into the way, let us say an important new way of thinking about atoms and subatomic particles. They are not parts of the manifested world. They are instrumental in the manifestation. They mark stages in a transition from one via formless particles, because the particles are in themselves, the fundamental particles are formless. Forms come into being when these particles form stable relations, like for example in an atom you have several particles in a combined state, and you have then not only these particles but the spatial relations, the relative positions and orientations internal to this system of particles, and that's what eventually builds up the forms that we perceive. So we start with formless particles, but when there are many, we can get for atoms which still have a form, which already have some kind of form, but this is not a visualizable form as yet. And then we come to molecules which are not fully but partly visualizable. And see, when you go to the chemistry laboratory, you see all these models of molecules, so obviously you can visualize them, but they have many quantum mechanical aspects still that you cannot visualize. So you have to treat that mathematically. So via non-visualizable atoms and partly visualizable molecules, you finally come to the manifested world. So it's a transition from one to many. Then there is another question, of course, that is just enter this new idea? No, this is precisely what I don't want to bother you with. Okay. So, but in the manifestation of the one to the one, we have to distinguish between two distinct poises of consciousness. There is a poise in which the one manifests the world to itself perspectively. And that means as if experienced by a multitude of subjects from a multitude of locations. Okay? We are all here in different places. We look at the world from different places. We have different perspectives on the world. But there is an original poise of consciousness in which the one manifests the world to itself perspectively, that is to say not perspectively, as if it were experienced from no particular location or from everywhere at once. Don't try to imagine it. And the mind can't do that, but that doesn't mean that the mind cannot conceive, doesn't exist. So, what then accounts for what was such a mystery to Schrödinger, this far-reaching structural similarity between certain parts of our experiences, is that we do in fact experience the same world from a multitude of locations. But this is a completely new way of thinking. That is not an external world that we somehow all experience, and we cannot understand the relation between that world and how we can possibly experience this, and how our experience can possibly agree with that world, because we can't put these things side by side. This is a new way of explanation, is we are all aspects of the one, The world exists in the consciousness of the one. And therefore, as aspects of the one, we are of course able to perceive the same world. We are just the one putting himself, itself, herself in many different places and looking at the world from many different places. Now, we have to take into account that all knowledge, again, according to Upanishads, so thanks to Schrödinger, we brought up the Upanishads. And according to the Upanishads, all knowledge, all experience is based on identity. The ultimate subject knows its objects by being at the same time the substance, the ultimate object that constitutes them. But now, if the ultimate, so there you have this, at the origin, knowledge by identity. Object and subject are one, not yet differentiated. But if the ultimate subject adopts localized standpoints, knowledge by identity is replaced by direct knowledge. Each individual knows the others directly without the mediation of representations. Oh, that comes in later. It's a direct knowledge founded on identity, made possible by the fact that subject and object are ultimately one. But if the ultimate subject identifies itself with each individual to the exclusion of all others, oh, that's our kind of situation. I'm not aware that I am you and you are me. It's an idea, but it doesn't feel to me like that, except in certain very special situations. So, if the ultimate subject identifies itself to the exclusion of all others, with a specific individual, direct knowledge of objects is reduced to an indirect knowledge mediated by representations. You see, the indirect knowledge of objects is still a direct knowledge, is a direct knowledge of neural representations. We know actually only what goes on in our brains. These are neural representations. But how is it? That is a big issue in the philosophy of mind. Is known as the problem of intentionality. How is it possible that what's going on in my head is perceived as something going on outside my head? And that can only be, in that Upanishadic or Vedantic theory can only be explained by the fact that this direct knowledge of the neural representation is transformed into a knowledge of external objects by or with the help of a subliminal direct knowledge. Something subliminal is going on below our consciousness. This diagram kind of tries to summarize the situation. First of all, our experiences, thinking of the brain, it's an important issue. What has the brain got to do with all this? No? The brain, the experiences that we have depend on, firstly, purely quantitative information derived from neural representations. All that's going on in the brain, all that electrochemical pulses and neural firing patterns and all that, so you can only describe it functionally quantitatively. So where does the qualitative information come from? That is the second big problem in the philosophy of mind is qualia. Where do the perception of quality, of color, for example, come in? When everything is quantitative that the brain can possibly provide. So, and I want to add an important point, that what is qualitative is not only things like colors, but also our very perception of space and time. Bergson, philosopher, insisted on that especially. He says, time is not only what we measure, it's a duration. And duration is an experience. It's the quality of time. If we just have a number, and say 5 seconds, that's not yet a time. It becomes a time because we know from direct qualitative experience what a duration is. We know that passingness of time as something, only as something that we know directly, qualitatively. It is not reducible to quantities. It is not extractable from the quantities that the brain can provide. So time is a quality that must come in from somewhere else in our perception of the world, because the brain cannot provide it. Same about the extendedness of space. You know, when we measure a distance, we have a number. But the number becomes a distance only because we know what a distance is. And we know what a distance is only because of our experience of space as this expands, which is qualitative, which is not reducible to numbers, and which you cannot get out of any kind of quantitative information. It is provided also, like all qualities, by a subliminal consciousness. So that's explained, sort of, or indicated in this pattern. From the object via the brain to the surface consciousness, you get insufficient information. But this is added, supplemented by an intuitive knowledge provided by a subliminal consciousness. And a subliminal consciousness can do this because it has a direct knowledge of the object. So here is this in Schrödinger's words. In the surface consciousness, knowledge represents itself as a truth seen from outside, thrown on us from the object, or as a response to its touch on the sense, a perceptive reproduction of its objective actuality. Since it is unable to observe the process of the knowledge coming from within, it has no choice but to accept what it does see, the external object, as the cause of its knowledge. In fact, it is a hidden, deeper response to the contact, a response coming from within that throws up from there an inner knowledge of the object being itself part of our larger self. So, there's a fantastic insight which solves the two major problems in the philosophy of mind, the problem of qualia and the problem of intentionality. Now I could go on, but I think it's enough. No? That is to say, there might be some questions, time-wise. I could go on, but it gets more and more esoteric.
I think at this point we can take questions, and if necessary, you can expand.
I will immediately address your question, which was about what? Just about the God particle, say something about the God particle. So the author of the book, I think it was Lederman, the book he wrote was called The God Particle. And it was about the Higgs boson. And Lederman actually wanted to call the book The Goddamn Particle. But the publisher said, no. And so it became the God particle. So why was it actually a goddamn particle? Because it took so long, so much time, so much effort, so much money to find the damn thing. So that's all to the God particle.
Questions? Anybody?
Yes?
So you were talking about subliminal consciousness. Is that being an agent that sort of gives the quality impressions of time and space?
It is, let us say, it is first part of ourselves, but a part which we are superficially in our ordinary consciousness not aware. But it is still there, it provides information. And it is in possession of a direct knowledge, that is to say, it can have this direct knowledge of what it perceives of its, it then has a much more profound knowledge of what is in the object, that is to say, what is the object qualitatively, and we have this superficial, quantitative, reproductive perception of the object, but that doesn't give us anything about its qualities, which is then provided, which is actually provided by a deeper self in us that has the direct knowledge of the object. That deeper self which has the direct knowledge is always there. No knowledge is possible without that. And in fact, the direct knowledge itself is only possible because ultimately all knowledge is knowledge by identity. It's always the one knowing itself. But differentiating itself into subject and object, and then complicating its existence by forgetting in each individual that it is actually one with all the other individuals. And that it can also know the other individual by the very fact that it is one with them. It can know them from within, so it can know them qualitatively, completely, which our external surface consciousness obviously cannot do.
So would you, I don't think you could say it's an agent, you could say it's a medium.
So it's in us.
The knowledge would be the
the
subliminal. It's knowledge.
Yeah.
Yes, it's the knowledge that the subliminal self has is a medium that allows the information to flow in, the information that appears to us to come from outside to actually sneak in from inside. Yes?
Can this one thing know itself completely?
The one thing knowing itself, of course, the one thing knows.
But excuse me, it seems that knowledge itself seems to create a separation, which would make a sense of incompletion.
I see your point, but this is a kind of a limitation that applies only to our present consciousness and to our present way of knowing. It is not the ultimate truth about knowing. The ultimate truth about knowing is identity, and that identity is only what makes any kind of knowledge possible. Because knowledge is a relation between the subject and the object. How is that relation possible? What is the medium between the knower and the known? It's only possible because the knower and the known are the same. Because all knowledge is self-knowledge. But the knower can stand back, and you see this is a fundamental act in Indian philosophy, this knower standing back from itself to create the duality of knower and known. You see, we know only the duality, so we seem to think that the duality is fundamental. It's not, you can't go beyond that. But in fact, duality is only possible because of an underlying identity. It's a differentiation of the one that comes. And it's actually, for example, that also when the one becomes many, you can imagine that there is one reality, one world. If we still want to use that word, it will be something extraordinarily different. But it exists in the consciousness of the one. But there is only the one, and there is no need at that point to distinguish between subject and object. The one experiencing the world and the one being and constituting the world is exactly the same thing. It constitutes the world by experiencing it. It's one and the same thing. But it becomes, the moment the one becomes many, that is to say, it looks at the world from many different points inside the world, then it looks at things from the outside. Then there is this distinction between subject and object. And it is actually only at this step, not previously to it, that our concept of space comes into being. Because then there is suddenly this dimension, this depth dimension where something is at the distance from me. And there is suddenly also the translateral, the two dimensions like this, where I see things from the outside. Before that, in the knowledge by identity, nothing is seen from the outside. There are no outside. Everything is seen from inside, from what it is, but not an inside in space, you know? Because the inside and outside is only created when you have this duality and start looking for the things from the outside. Then we have this normal, ordinary concept of inside. But there is a deeper inside, which is where the knowledge by identity operates.
Well, perhaps can we have identity without knowledge? Because it seems like
Yes.
knowledge
Yes.
complexifies things maybe unnecessarily.
Oh, sure, but not necessarily. In fact, yes, but not necessarily. And yes, there's a state. Okay, I'm just, you know, I'm not talking from my experience. No? I'm just representing ideas that you find in Vedanta, in the Upanishads, and in Sri Aurobindo's philosophy. It's very, very important to distinguish all the possible states of consciousness and beyond and beyond and beyond. So, and where all the words that are really derived from our experience and words of our language which apply to our experience, none of our words really apply there anymore in those ranges of consciousness and ranges of experience, you know. But you can say that in a kind of nirvana, there is no differentiation between subject and object. There is no knowledge. There is pure awareness. And you can, you know, according to the different traditions, according to the different language that you use, you can say there is pure being, or you can say there is pure consciousness, or you can say there is nothing. Because there is nothing that we can talk about with our familiar language. But that's that. That's the origin of everything.
When you say there can be identity without knowledge, but there is no word. If there is not identity with knowledge, that implies there's a word.
There is something to be known. But then there can also be a self-knowledge, that is to say, a certain gentle, subtle self-differentiation,
Sure.
where the one ecstatically experiences itself as an object, but that's that. There's still no word.
That's true. That's very interesting. Kashmir Shaivism talks about 5 different stages of going from identity to word.
Yes.
And these are some of those stages where there is just that subtle self-knowing, but not the full multiplicity. So it's not knowing.
Right.
So for the identity, can we have the identity without knowledge of the identity? Or can we have the awareness without knowledge of it?
See, you can have the awareness of so many things without having labels, putting labels.
But I mean,
on
is it-
them, you know, that's just to say, I mean to say, without having words for them. Let us say, beyond the few things for which we have words, there are infinitely many things for which we have no words, you know. So it's always a big challenge for our language to say something about higher states of consciousness.
But do you see awareness itself as being something that we can have directly without knowledge of it? I mean, in other words, we can just be in awareness without somehow knowing that awareness exists at any level, or that there is awareness.
Well, when you say awareness, of course, some kind of object has to be there of which you are aware. And there is a possibility of self-awareness, which involves a minimal initial separation, distinction between subject and object. But it's not an ultimate state of consciousness, if there is such a thing as an ultimate state of consciousness.
Well, it brings in knowledge again.
Awareness
if there has
and
to be an
knowledge
object.
go together, where there is awareness of something, that awareness itself is already a kind of knowledge.
And perhaps,
He's not making the distinction between knowledge and awareness as you are. Awareness itself is knowledge.
It's a way of knowing.
Yeah, it's a way of
but of knowing what? I mean, can there be empty? Can there be empty awareness without any knowledge in it?
You can be aware of, for example, that state of it would, if there is nothing structured,
Yeah.
that would correspond to our more ordinary concept, which then ultimately becomes scientific knowledge, which is only a knowledge of structures, which is there is no structure as yet. There can still be an object, a knowledge or an awareness of an object where you could say that is the very, very first minimal beginning of structure, namely the distinction between a subject and an object, a subject being aware of itself as an object, or a reality differentiating itself into an experiencer and an experienced. That would then be the very basic structure, this simple initial relationship, and no other structure as yet. That is to say, the object would still be unstructured, but it would be an experience. It would not, an experience without any normal, ordinary kind of knowledge, what we normally understand. There is no structure in it that we normally understand as an object of knowledge, something that is known.
Do you see that one as that?
The one as?
The one object, or the one molecule, is that structured or not structured?
No, when I look at this transition, and I say the physical experiments so strongly suggests, as Fineman clearly said, but he talked about one particular species of particles. He said, I know why all, Wheeler told him, I know why Wheeler was his teacher, was a student of Einstein, very, very famous physicist also. The physicist who invented the concept of the black hole, should be known who that invented that concept. So, as a student of Einstein. So, Wheeler told him, I know why all electrons have exactly the same properties, because they're all the same electron. Simple explanation. Here also, in that situation which is otherwise inexplicable, why can we not say which incoming particle is identical with which outgoing particle? It's because they are the same particle. The same thing doing different things. And that's ultimate reality. So when something then is manifested, it is manifested out of the relations between this thing and that thing, which is to say the same thing doing two things. That is to say, entering, at the very moment, basically the one enters into relations with itself, assumes, adopts relations, entertains relations, choose your word. You have a multitude, an apparent multitude of related things. There's a multitude, and yet the things which are related are one, and what is many is only the relations. And the multitude of relations manifests forms, constitutes forms, and forms constitute the manifested world, the world we perceive, the world that exists, manifested to us, that exists in our consciousness. It's not manifested in a vacuum, It may be manifested in the consciousness of the one, but it is not manifested in nothing, or to nothing. It is always manifested to a consciousness. So we go from the one to the many. There are many, many ways, sorry, not so many, but three fundamental ways in which the one becomes many. They are indicated here in my next slide, which perhaps we can still discuss. We have this transition I've been talking about from the one via particles, atoms, and molecules to a world that is incompletely manifested in an incompletely evolved consciousness. That's us. But maybe the world we are talking about is the world as it is manifested to us right now. It's not the world as it is in itself. And because consciousness evolves, the world will evolve, and it will not evolve by us tinkering with it, but simply by a change in our consciousness of the world. Because the world only exists in consciousness, so a change in consciousness can make a dramatic change in the world. I guess that's our only hope, that some such change will occur. So then there are two more ways in which the one becomes many. When we start with the one ultimate, let's say, as a subject, I said, when it assumes this many different perspectival awarenesses, points of perspection inside the consciousness of the one, looking at the world, the one looking at the world from many places in the world, becoming therefore many selves aware of their mutual identity, and then become further down to a multitude of partly conscious beings no longer aware of their mutual identity. And then we can go further. You see, it's an increasing limitation of consciousness. When we then experience ourselves no longer as being identical with each other, but as separate individuals, we have, in Windows terminology, basically descended from the supramental consciousness to the mental consciousness. And that is a process Sri Aurobindo calls involution, which is basically an increasing limitation of an originally unlimited consciousness. And so then a further limitation is possible where we come to submental forms of life. That is to say, forms of life that are no longer conscious the way we are conscious. When we have a further suppression of life itself, that is to say, because in Sri Aurobindo's view, life itself is responsible for the existence of forms. It is the power, the force, the prana that actually creates the forms. So when we suppress that also, when we involve that also, we come to the multitude of formless particles. And then we have to ultimately realize that all these many formless particles are actually all the same one. So we have a descent from the one to the one. That is involutionary. It is there can be a reality to it. There is a reality to that process. According to the occult traditions, there are different worlds, all corresponding to these different possible stages of consciousness and different degrees of involution. And then there's the reverse process, and that's evolution, where we start from the one and then we get, basically you can say that it's a form of a way of thinking of the Big Bang. The one explodes into a multitude of formless particles, and suddenly there are relations, and where there are relations there can be forms, there can be objects. So then there is evolution, first submental forms of life, organic, inorganic matter, then we have evolution of partly conscious beings, not yet aware of their mutual identity, that's us. And further on, the evolution of beings that are completely conscious, completely aware of their identity with the one and with each other. No? So two processes. But there's more. There's a sneaky indication that there is more. I don't know. We go further. Any other questions?
Yeah, I wanted to ask about non-locality, and you indicated there's nothing like objective time. Is there objective space? Or did I misunderstand?
No. The objective time and the objective space are the time and space of our consciousness objectivized. The three possible words: objectivized, objectivated, objectified. That is to say, we are able to think of these forms of, or Schrödinger used to call them forms of perception, these most general forms, a completely Kantian concept, no? That space and time are the general forms of our experience. They become objective by thinking about them as objective. There is not an objective reality out there independent of us. There is only the objective reality anchored in our experience, but structured in such a way that we are in a position to think about it without thinking about ourselves. As Schrödinger so nicely said, that in the beginning, in that quotation, we step back from the content of our consciousness. And this stepping back allows us to think of the content of our consciousness as if it existed independently of our consciousness all by itself, which is a big illusion, but we get by with that quite well.
So in non-locativity, there are two particles.
That is a completely different situation. Yes. Right.
Who know about each other and they can interact.
Oh. Of course, this metaphorical language is used, can be used, that particles know each other. But you see, it's all correlations, quantum mechanics is all correlations about measurement outcomes. So there can be particles in a state, particles described by quantum mechanics in a certain way. So you have one particle here and one particle there. And when you make a measurement, you perform a measurement on this particle, you get certain information. And the correlation between these two particles consists in the fact that on the basis of your measurement outcome here, you can make prediction of what will be observed, what will be the outcome of a measurement over there. You know? So it is always a correlation between measurement outcomes. Now the question is, of course, how can we understand this correlation between measurement outcomes? You know? And there are basically just two ways of understanding this correlation. Either there is a direct influence. What I do here, by measuring and obtaining a certain outcome, I influence the situation over there, and this influence then determines the outcome I obtain here. So that can that could possibly explain the correlation, how the correlation comes about. There are several issues here, because when the two measurements are made perfectly at the same time, you cannot even know, does the influence go from here to there, or does the influence go from here to there? Does this outcome influence that particle and its outcome, or is it the other way around? Anyway, the whole point is ruled out, let us say, that kind of explanation is ruled out by the special theory of relativity, which does not makes it impossible for any direct, instantaneous influence. No, you've all heard probably this, if you heard anything about specialty of way of relativity, is that it prevents information from being propagated faster than the speed of light. So instantaneous propagation of anything, any kind of information from here to there, is not possible. So there is only then the other kind of explanation, which involves a common cause. So the particles originated locally in one and the same place in a correlated fashion, and then they moved to different places. And you can then understand the correlation because there was a common cause, there was a locality, they were in the same place originally. Unfortunately, that explanation is also totally ruled out. And it was in 1964 by John Bell, famous Bell's theorem, which absolutely ruled out the possibility of a common cause. That is to say, to illustrate the common cause concept a little bit.
Yeah.
The ice cream company made a statistical analysis and discovered that when ice cream consumption goes up, the number of deaths by drowning goes up. And so the question is, does the increase in drowning incidents raise the consumption of ice cream, or does the consumption of ice cream increase the number of... Is there this kind of correlation? No, obviously not. But in this case, there's a common cause. No? It's the weather. When it's warm, more people go swimming, more people eat ice cream, and more people drown. No? So obvious correlation. Has nothing. You can't blame the ice cream. But there is a common cause. But the quantum mechanical situation is precisely that Bell's theorem completely rules out the existence of a common cause. It's always in quantum mechanics that you make certain common sense assumption, and quantum mechanics immediately tells you no. Because you get, from the moment you make such an assumption, you get a prediction which is contradicted by quantum mechanics. So the assumption is wrong. It doesn't work. And so that's non-locality. A local explanation of this correlation is not possible. Local would be something traveling from point, like a bucket brigade from point to point. And that would be a local, something travels from point to point. That's what one understands by local. Or the particles were originally in the same place, and then the origin of the correlation is again local, because the correlation has then been transmitted from this one origin point to those separate places at which the particles are situated. So no local explanation works. And that is a fact of non-locality, the issue of non-locality. There are many interesting situations, and theorems have been, many different theorems, meanwhile being proved that, local explanations, which is a basically common sense of explanations, simply do not work. Some physicists, they explained it nicely that writing that physicists are actually a naive breed trying to explain everything like a kick of a football, That's to say, there's a direct contact. And we had this beautiful slide in the conference by Ruth. She showed a bucket brigade, when people, they passing on buckets of water, one to the next, And that is a naive understanding of how an influence can travel from one place to another. When all that traveling, we are normally so naive that to understand that something here can have an effect on something over there, we always need the idea that it's something is an influence that travels. So the electron kicks the ether kicks itself, goes on wiggling The next bit of ether is being kicked, and it goes on kicking the next bit of ether, and so the wave propagates, and finally it kicks the other electron, and that starts wiggling. So, and classical physics, with the help of Kant, was kind of acceptable, which was built on that notion, and quantum physics says no way. And so we have no way of understanding what's going on there. Well, we have an way of understanding that about what's going on, but can't say that it is widely known or accepted.
Thank you for your talk. Can we then maybe try to imagine the separated particles as not being separated, as actually still?
That's it. They are all aspects of the one. They are not really separate. They are the same thing in two different places. And what is more, when we think about the distance, what is a distance? It's also a relation between the one and the one. So, when you think of, quantum mechanics does not, when we go to divide objects in the naive classical way of thinking, we kind of cut them up like with cookie cutters. We get smaller and smaller objects, seem to be always the same stuff inside, we get just smaller bits of the same stuff. First of all, quantum mechanics says there's no stuff. Then there are relations between the one and... So the fact that this division into smaller and smaller bits of matter that are all distinct from each other, that doesn't work. Because ultimately you end up with a multitude of formless particles which are all numerically identical, the same thing. So instead of creating more and more stuff, you end up by, there's only one thing. That is the distinguishability of objects suddenly evaporates when we keep dividing. There is not more and more objects in the end. There is one single object in the end. But a similar thing happens with space. Because when we want to distinguish between regions of space, that also is not possible. The question is, how far can we objectify or think of the division of space into separate regions? How far does quantum mechanics allow us to think of that division of space into separate regions as being objectively real? How far can we objectify it? And there's a limit. And so, as we can say that ultimately there is only one thing and that is everything, you can also paraphrase this situation with regard to space, that ultimately there is only one place and that is everywhere. So it's, okay, it's like koan, Zen. Yes?
One more. I really appreciated where you began with Schrödinger and about my consciousness and your consciousness and how we communicate to agree on what we experience. But then at the same time, there's this way in which it seems there's subliminal information that we experience and we receive. And I have this hypothesis that yes, we have consciousness that is our own experience of it internally in a sense. But there's this way in which consciousness is also something we share. And it's like a field, like electron field or whatever, that's something that participates.
No, you don't. I perfectly agree with what you're saying. And just a little note of warning, you can talk about field freely. You do not need to involve the physical concept of a field, It's kind of, that people often do use metaphors from the field of physics which always makes it seem as ultimately you anchor your arguments in physical reality. No need to do that. There is a field. You can't say like a physical field. What does it do with physics? You're not talking about physics, you're talking about something much more important, much more real. No, but you see, the subliminal consciousness is precisely this subliminal knowledge we obtain is precisely from a self that is no longer our own separate personal self, because that is one, first of all, with the knowledge, and that's why it can supply knowledge about the object. No? It is one with the object known, and only on the basis of that oneness you can have this knowledge supplied by your subliminal self. So it's not only yours, it's also there in the object that is known, and it is there in everyone. So the more you go into the subliminal or away from your surface consciousness towards more truly towards your real self, of course you come, like in one direction you come to one particle, one object only, in the other direction you come to one self, one consciousness only. The more you go within, the more you are one with others. You go all the way, you are totally one with everything. Yeah?
I think you said it was Niels Bohr who didn't allow to go in infinitely. He didn't allow, you can't just perceive in a continuum forever.
Yeah.
Someone, it was him, I think, who truncated the process. And I just wonder to what degree that relates to this phenomenon called the identity of indiscernibles, that Leibniz talked about, when just because we can't tell that they're different doesn't mean that they are different or even are the same. There's like a breakdown of perception.
Yeah.
And so I wonder to what degree what you're talking about the one electron moving around, is that only a conventional description based on the limits of our perception, or is it the actual, can we actually say anything about reality other than just our own perception of it? I know that this is basically what you've been talking about in different ways, but...
With regard to that identity and difference issue, that was a profound issue already in medieval philosophy. Yeah. The scholastic philosophers, they used to discuss things like, you imagine two completely identical objects in two different places. Completely identical, but in different places. And then the question is, well, are they two different objects, or are they one and the same object in different places? And you say, two objects in two places, or only one object in two places? Now, when you say, no, there are two distinct objects, then how and why are they distinct? Because distinction are based on distinction of properties. And we are assuming that they have identical properties, except that they are in different places. But if I take an object from here and put it in a different place, I don't think it becomes a different object. No? The place does not label an object. Being in one place is not enough for an object to be a distinct object. No? These two objects should be regarded as the same object in two places. It sounds absurd, but the assumption that there is something materially distinct between those objects, even if there are no properties that are different, that leads to a lot of nonsense also. So these, scholastic philosophers, they used to define matter in two ways. They say matter is what is the same in things with different forms, and then they would say matter is what is distinct in things of the same form. It's silly, no? But it just shows the issue, which is only resolved by concluding that, if there are two things with exactly the same properties, they're indiscernible, then they are one and the same thing. If they are in two different places, so be it. You know? And quantum mechanics then makes it absolutely clear that's how it is.
But I think indiscernible relates very importantly to our limits of perception that we can't discern. It might not.
No, but you see, that is true. That is, but in quantum mechanics, we are dealing with particles that are so totally minimalistic. They have such a minimal set of possible properties that it is absolutely possible and very easy to have and deal with particles which are absolutely no differences between them except that maybe they move in different directions or maybe they are in different places. You know? You see, the very assumption that there are distinctions we are not aware of leads to predictions that are contradicted by quantum mechanics. We can't make that assumption. Please don't ask me to explain that. You know, that involves a lot of mathematics.
That makes sense.
Well, I did have a question on where the actual distinction comes from. So we just talked about these atoms, and we can say that it's non-local because they're sharing the same space in oneness, right? But you can register and you can take a measurement that there's a corresponding movement between the two of them as distinct from the entire world and all of the universe also sharing in that oneness, also moving in the same way. So how do you actually measure distinction in oneness?
How would you measure it?
Well, it sounds like it's a qualitative distinction rather than a quantitative distinction. And so how do you kind of, I guess, find those qualities that are distinct from a sea of oneness?
I'm not exactly clear about what you're saying, but just keep insisting on one fundamental fact about quantum mechanics, then the conclusions, the philosophical conclusions we are kind of compelled to draw is because the moment we make a commonsensical assumption to understand something, quantum mechanics very clearly tells us, nah, that's not how it is. Because we can, on our common sense assumption, make calculations and predictions, and when we compare these predictions with what happens in actual experiments, we see our predictions are wrong. So basically, we are not getting really any positive information, we are only getting it by elimination of all the possibilities. So where everything commonsensically is rolled out, then the one non-commonsensical thing remains.
That's quantum.
Such, for example, we are compelled to acknowledge the identity of things that we cannot distinguish, which rules out that there are distinctions that we are not aware of. That is ruled out, you know. Even if there are distinctions that we are not aware of, then our predictions are different from the predictions of quantum mechanics are different from the predictions that we get when there is nothing by which, nothing distinct between the two particles. So it's not a question of whether there are properties that we are not discerning and distinctions that we are missing, It's not that. Quantum mechanics clearly tells us this behavior that we are observing is possible only if there are no distinctions of any kind.
At that level.
Which level?
At the quantum level.
All right, at the quantum level, there is no distinction.
Yeah, but okay, but if every molecule is made of atoms and every atom is made of particles and all these particles are ultimately one and the same thing, that's a relevant implication. No? Did we start at 3 o'clock?
Okay.